Hello everyone, this is our group project. I'm Sathvik, we have Benson, Rochelle, and Mithun in our group, and we'll be covering L'Hopital's rule today. So essentially, L'Hopital's rule occurs when you have a limit, and you have a function in the numerator and the denominator, and when you plug in the x value, you get 0 over 0 in your numerator and denominator, which is an indeterminate form. So in order to solve this, we solve the derivative of the numerator and the denominator, and then plug in our point again to solve for the limit. All right, so our first problem is limit as x approaches 0, x squared over cosine x minus 1. So we set the numerator equal to 0, we get 0 squared equals 0, and we get cosine 0 minus 1 for the denominator, which is 1 minus 1, which equals 0. So now we apply L'Hopital's rule, which would be finding the derivative of the numerator and the denominator. So we'd get 2x in the numerator and negative sine x in the denominator. So now we do the same thing again. We make the numerator, we plug in 0 to the numerator, we get 0 again. Plug in 0 to the denominator, and we get negative sine 0, which is 0. So since we get 0 over 0 again, we have to apply L'Hopital's rule for a second time, which would mean finding the derivative of the numerator and the denominator. So we get 2 in the numerator and negative cosine x in the denominator. So now we plug in 0 in the denominator because there's only x there, and we get negative 1. So we get 2 over negative 1, which is negative 2.
Now, let's move on to the second question. As limit x approaches 0, tan 3x over sine 5x. This is the question. So before using L'Hopital's rules, we need to plug in 0 on top and bottom to make sure we're getting 0 over 0. So then only we can proceed with L'Hopital's rule. So here we can see we are getting 0 over 0. So now let's rewrite the equation. So we need to write in a vertical format. So again, let's say limit x approaches 0. We need to take the derivative of tan 3x, which we get 3 secant 3x squared. We need to take the derivative of sine 5x, we get 5 cosine 5x. And then we are going to factor out 3 over 5. So let's rewrite the equation in the vertical format. As limit x approaches 0, we get 3 over 5 times secant 3x squared over cosine 5x. So now we are going to plug in 0 on top and bottom. So we get 3 over 5 times secant 3 times 0 squared over cosine 5 times 0. So we get 3 over 5 times 1 over 1. As secant 0 squared over cosine 0 squared, we both get 1. So answer is 3 over 5.
Okay, for this problem, we'll be doing limit as x approaches 0 for e to the power of 2x minus 1 over sine of 4x. Next, you apply the derivative to both the top function and the bottom function. Don't forget to write your limit as x approaches 0 there as well. Once you apply the chain rule for the numerator, you should get e to the 2 of x times 2, and then for the denominator, you should get 4 cosine 4x. Now, after we're done applying the derivatives, we can plug in, and we plug in 0 to the top function, you get 2, and then 0 to the bottom function, you get 4, and then that just simplifies out to be 1/2. And that is your answer.
Okay, so this is number 4 for using L'Hopital's rule, and we can only use L'Hopital's rule when it's equal to 0 over 0. So for the initial problem, when you plug in 0 for the numerator and denominator, we do get 0 over 0. This means that we have to differentiate both sides. If we differentiate both sides for the numerator, which is e to the x minus 1, and differentiate the denominator, which is cosine x minus 1, we get e to the x minus 1 over negative sine x. So now we have to take the limit of that as x approaches 0 to make sure that it is indeterminate form again. So when we do limit as x approaches 0 of e to the x minus 1 over negative sine x, and we plug in 0, and for the numerator and denominator, we get e to the 0 minus 1 over negative sine 0, and this is 0 over 0 again. This means that we have to differentiate a second time. So when we differentiate the numerator, which is e to the x minus 1, and differentiate the denominator, which is negative sine x, we get e to the x over negative cosine x. And now when we plug in 0, limit as x approaches 0 of e to the x over negative cosine x, we get 1 over negative 1, which is just negative 1.